Basic architecture. When Juniper engineers designed the Junos operating system, they did a number of really clever things. First, they divided the functions into three separate planes. You have the control plane, the services plane, and the forwarding plane. They also separated the engines, if you will, so you have different processing resources, memory, and other resources for the packet forwarding engine versus the routing engine. Because of this, Junos is capable of running on various platforms, large, small, and in between. So what we have here with Junos operating system is a platform that separates control traffic from forwarding traffic. First, let's have a look at the control plane in more detail. The various processes and functions representing the control plane run on what's called the routing engine. From a very high-level view, the control plane consists of a number of modules and the OS kernel, which manages and controls the modules and any communication between them. The kernel handles the control traffic, and so you should take away from that the fact that it also manages communication between the routing engine and the packet forwarding engine. Modules in the control plane are considered control traffic, and these modules include, for example, modules to control and maintain the chassis, modules to control and maintain Ethernet switching, and modules to control and maintain routing protocols. On the forwarding plane, the packet forwarding engine does what it does, and that is to efficiently move data packets in and out of the device, that is the router, switch, or security gateway, so the PFE could be considered the central processing element on the forwarding plane. There is also a locally stored forwarding table that the packet forwarding engine uses. This table is a synchronized replication of the forwarding table from the routing engine, and it, by the way, contains all the information needed in order for the forwarding plane to handle the data packets, including outgoing interfaces, IP addresses, and other information. Because it stores a local copy of the forwarding table, the packet forwarding engine doesn't need to consult the routing engine on the control plane each time a packet is processed. So, the packet forwarding engine can even forward packets during a disruption since it has that local copy of the forwarding table and since the system is modular in nature. Now, the services plane, there are many different packet types that require special handling. For example, network address translation, firewall, security policies, and so on. This is performed on the services plane. Because Junos separates the processing of services from the other operating system functions, it is capable of supporting quite an array of different service types across different platforms. As an extension of the data plane, the service plane performs stateful packet inspections. And there's a services software development kit that allows developers to develop applications that can run on the services plane, such as traffic shaping applications or monitoring applications. So, in this video, you had a look at the basic architecture of the Junos operating system.